Hi all, my name is Satrio Jaksono, okay, and I'm here to explain the concept of bending. In the real world, there are a lot of cases where bending happens, such as on the right, there is a truck which is under bending due to the load, and on the left, there is a wing of an airplane which is under bending. Okay, what should we do in order for us to calculate for the stress which is happening due to bending? That's the thing that we will learn today. As you can see in the figure on the left, there is a beam with square cross-sectional area. If this particular beam is under pure bending, it will be deformed like in the picture on the right. Okay, as you can see, the line which is initially horizontal will become curved like this. And then the vertical line will remain straight, but it rotates. In order to make it clearer, I will give you another example. As you can see here, there is another beam. This particular beam has axis of symmetry y like this, longitudinal axis x like this, and natural surface like this, which is going through the longitudinal axis. When this particular beam is under bending, the deformed shape will be like this. As you can see there, the natural surface, which is initially straight, will be deformed like this. And the longitudinal axis, which is initially straight as well, will be deformed like that. The next thing that we should do is to analyze in detail this particular small section before the bending happened and after the bending. This is the section before the bending and when the bending happens. Okay, as you can see, at the natural axis, the length here will still be the same. Initially it is delta x, and when the bending happens, it's still delta x. But at the other location, it will be different. For example, at the distance y from the natural axis, the length here is delta s before the bending, and when the bending happens, it becomes delta s xz. And as you can see, when the bending happens, pure bending, the beam will have certain radius. In this case, it is rho. And if we calculate for the strain, as you can see here, the strain will be proportional to the distance from the natural axis y and inversely proportional to the radius. Based on that results, we can see that this is the strain distribution at that particular section. You can see there that at the natural axis, the strain is 0, and it gets bigger when the distance y is bigger. So, we can see that the equation for the strain will be like this. And because the stress distribution is proportional to the strain distribution, as you can see, this is the strain distribution, and this is the stress distribution, then we can find that the equation for the stress will follow this particular equation, which is 0 in the natural axis and maximum at the farthest distance from the natural axis. Then, if we do the integration of the stress at the cross-sectional area, like this, okay, what we will get is this particular equation. This particular equation is actually the same as the centroid equation. That's why from this, we know that the neutral axis is passing through the centroid. The next thing that we're supposed to do is to find out the relation between the moment, the given moment, and the stress which is happening at the beam. How can we find that? We can do that by integrating the stress which is happening at a small element like this, sigma dA, and we multiply it with the moment arm y. Then we integrate that at the cross-sectional area. By doing so, we will be able to get this particular equation, which actually shows us the relation between the moment and the maximum stress. And you should notice that this particular equation is actually the equation for the moment of inertia. That's why we can conclude that the maximum stress will be equal to the moment multiplied by the farthest distance from the natural axis divided by the I moment inertia. And to find out the stress distribution, we can use this equation where the stress is equal to minus moment multiplied by the distance from the natural axis divided by I. To ensure that you all understand all the things that I have taught you in this particular video, let us discuss one problem example. As you can see here, okay, the things that we're supposed to find here is the maximum stress which is happening at the beam due to this particular moment, 40 Newton meter. The first thing that we're supposed to calculate is the moment of inertia. We can calculate the moment of inertia using this equation because the shape of the cross-sectional area is rectangular. That's why we can use this particular equation. After we calculate all, this is the results of the moment of inertia. Then after that, we can calculate for the maximum stress using this particular equation. And the results is 4.44 megapascal. That's all for this particular video. Thank you very much.